Okay, now it's solutions to question 3. Okay, you can read the question by yourself. Now we move on to the solution. Okay, now we have here the height of the jar. Our small jar is 10 cm. Okay, so what we do is this. If you notice, okay, the big jar, actually what we can do here, we can write it out for you. H over 10 is equals to 8 over 5. We are comparing the ratio of lengths. So simply H is equals to 8 over 5 multiplied by 10 on both sides. You get the working here. Your 5 by 10 is 16 cm. Next part, we have to calculate the ratio of the surface area. As we know, L1 over L2 square is equals to A1 over A2. So we just square 5 square and 8 square, you get 25 over 64. For 3C, what we have is the cost of a large jar, okay, and the cost of a small jar is 210. Cost will be related to volume. So what we do is, first we want to find the ratio of volumes. So what we've done here is we take 5 cube and is to 8 cube, because V1 over V2 is equals to L1 over L2 cube. So we cube both sides. The ratio of volumes of the small jar to large jar is 125 is to 512. Okay, so now the cost of the jar of jam should be proportional to the volume. So if I can clarify this working over here, what we're actually doing is this. The cost of small jar is 210. Okay, the cost of large jar, okay, let me call it cost over 210. It will be proportional to the volume of the jar itself. 512 over 125 over here. So what happens here now is this. We multiply both sides of the equation by 210. Down here, 210. Alright, what you get is that the cost of the large jar is $8.60. And that concludes question 3.